Video. I'm going to carry off of the last problem we did for 6.2 with the chocolate bar and calories, mostly because I've already drawn up these charts and stuff, and we're going to kind of continue that on. What you'll notice that the particular problems I'm going to do are not in your textbook, but I'm just going to use them as reference to the problems I'll talk about. So take a moment, maybe pause the video and just see if you can interpret what I'm asking here. So I'll reference it before, of course. So what I'm asking for is give me the cutoff score for the top 16%. So with the data here, you're going to kind of work backwards. So we're going to try to find out, well, what calorie count would give me the top 16%? And vice versa, what's the cutoff score for the lower 25%? All right, now these graphs right here, again, I'll reference these. But just take a moment, maybe pause the video and take up a couple ideas that you think you can use. All right, so let's dive into this. So the first thing I have to do is it's kind of like you're going to actually work this problem completely backwards, okay? So the first thing you need to realize is that when we talk about the top 16%, if you visualize that here, I'm going to try to draw a nice bell-shaped curve. Getting better at it. It's always the end that gets me. So if I'm talking about the 16%, so say I'm just going to randomly draw, let's say this part right here is 16%, okay? So that would make, in our table we have here, you'll notice that as we talked about through the last couple of videos, is this gives me the area of the left side. So I don't really care about this. I more care about, like, I got to find this z-score. This z-score is what I need, okay? So I have to think of, well, what z-score produces the bottom 84? So like as we recall that a bell-shaped curve adds up to 1. Let me rewrite this just a little bit here. Give me 1 second. Instead of writing 16%, I'll write 0.16. Maybe that'll be a little bit more visually appealing. All right, so I want to know what this area is, but we know from our standard normal distribution chart that it only gives us areas to the left. So we're going to try to find the z-score that is closest to 0.84. The reason why I chose 0.84 is because those two added together equal 1, which is what the area underneath the standard normal distribution equals. So what I'm going to do is I'm going to go to my chart. This is where you got to remember this. It looks a little bit deceiving because 0.84 is kind of the same rounded or to the hundredths place as our z-scores, but understand I'm going to look here because I'm trying to find the closest thing to 0.84 on this chart, okay? So I'm going to look around here. Let's see, 0.82, 0.82. I'm getting closer to 0.84. As I get closer, it looks like this one is 11 away. 0.0011 away, and this one is 0.0013 away. So the z-score that produces the closest thing to 0.84, or 84% of the data, is this 0.99. So let me just reference that here. So do you see that this is the closest probability to 0.84 is 0.99? So that's going to be the z-score that gets closest to what I want. So this translates to, I kind of like to write it like this way, 0.84 translates as a z-score, let me draw a better arrow here, as 0.99, okay? So if I were to type in that z-score into the chart, I would get 0.84, which is what I want. So now I'm going to go up here to use this nice z-score calculator. Well, if I know the z-score, let me put the z-score in blue. All right, this is the found z-score, and it equals, we know what the mean is, we know what the standard deviation is, but I'm trying to find this. This is the value I'm trying to find that creates that cutoff score for the top 84%, or sorry, the 84th percentile in a way is what we're trying to figure out here. So what I'm going to do is just work backwards. I'm going to use a little bit of algebra skill. I'm going to take both sides times 10. Again, I'm trying to solve for x. So we get 9.9 equals x minus 225. And if I add both sides plus 225, I get x equals 234.9. Okay, so let me write that workout so you can see that. Plus 225, and so I get 234.9. So if you want to work back, so what we did is work backwards, but if you want to work forwards again, you could type this into the z-score, find the z-score, and then you'll find from the z-score that would give you a 0.99. Then you go to the chart and you find that's 0.84, which it's, again, we're working all in unison, I guess. So one way and back the other way. All right? So let's try this one. Now that you got a second to kind of look that over, see if you can kind of walk through the steps with part B here. So maybe put the video on pause to get practice. All right, so now I'm trying to look for the lower 25%, okay? So if I look at my chart, let's see if I do my bell-shaped curve, a little bit lower. Standard deviation is a lot higher number there. So if we are looking for the bottom 25%, let's just say that's 25, and I want to find out what this is. So I'm saying 0.25. So you'll notice that in this case, I'm looking for that area, the z-score that produces an area of 0.25. So I don't have to worry about looking at the other side of things. So I'm going to go to my chart, try to find the closest thing to 0.25. Because it's less than 0.5, it's going to be in the negatives. So let's find out here, 0.25, rolling here. Here we go. So I got this one is 0.014 away, and this one is 0.0017 away. So this is the closest thing to 25%, if you notice there. So negative 0.67. Negative 0.67. All right. So if I take 0.25 and I transfer that into a z-score, I get negative 0.67. All right, so now I'm going to use the calculator here, or my z-score formula, to find out what that value of x that would give me a z-score that I want. So let's see, x minus 225, I'm getting the mean from our original problem here, divided by the standard deviation equals the z-score I want to find. I do times 10 to both sides, so that would be x minus 225 equals negative 6.7. And then if I add both sides plus 225, I would get a value of 218.3. So x equals 218.3. So that is the value, or the caloric, let's see, the calories. 218.3 is the cutoff for the lower 25% of our data set. All right. So this video, I'm going to do one more video on the middle problems, but I wanted to give you guys a chance just to see if I was just asking for either the top or the lower. So I will make a part 3 video for you. So thank you, and please come with your questions for our office hours.